Hey, all you Bundesliga fans. Today we're going to talk about right triangle trigonometry. Kind of sounds like Bundesliga. Anyway, so everything we're going to deal with today is going to involve a right triangle. All right. So something looks like this. There we go. Maybe. All right. And so we're going to put here a mnemonic device for you to remember how to deal with this. Okay, so that mnemonic device is this: SOHCAHTOA. SOHCAHTOA, and what it stands for? These three letters right here, S, C, and T. Those stand for sine, cosine, and tangent. And perhaps you've seen those three buttons on your calculator and wondered what those are, but there you go: sine, cosine, and tangent. Now the rest of these, so there's three parts here. The sine, that stands for, the O and H stands for the opposite. I'm going to abbreviate these, over the hypotenuse. The cosine stands for the adjacent over the hypotenuse, and the tangent stands for the opposite over the adjacent. That's what each of those letters mean. O is always opposite, A is always adjacent, and H is always hypotenuse. Well, what does that mean in this right here? Well, so hopefully it makes sense that this is our right triangle here. We're going to call this C. We're going to call this, you can call it A or B, however you want to do it. All right. And let's say this is the angle that we're dealing with, angle B right here. All right. And so what we have is, obviously, I think, you know, this is the hypotenuse. Okay. Now, when we're dealing with the opposite or the adjacent, we're dealing with the legs. Well, this one right here is the adjacent leg, and this would be the opposite. Okay? Now, if we change that, all right, let's put that in a lovely color of green there. So the greens all go together here. But if we changed our focus to, let's see, how do I want to do this? If we changed our focus, here we go. If we changed our focus to the A, all right. Well, now when we change our focus to the A, this is still the hypotenuse. Okay, so if A is our angle now, well, now this side is opposite, and this side is adjacent. Okay, let's talk about how to use SOHCAHTOA, all right, in an example, and that's pretty much all we're going to do today, because that's all this section is going to entail. We'll do some extra examples in class to hopefully help you out, but this is all we're going to do. So let's take a look at an example. So here we have an example. We have a right triangle, and we only need to know two of the angles. We're always going to know that it's a right triangle, and we're going to know one of these angles. But right now we know that this length right here is 14.5. And what we're going to do is we're going to find these two sides right here. Okay? And so we're going to use this idea right here. And let's use 26.3 degrees. All right, let's use 26.3 degrees, and we'll see if we can't find these other two sides. All right, let's tackle this one over here first. All right, and so if we're using this angle right here, this side over here will be labeled the opposite because it's away from it. And this side right here is always the hypotenuse. It doesn't change. Only the opposite and the adjacent change. If we chose to use 63.7 degrees, then this would be the adjacent side right here. All right, so how do we set this up? So the sine, and sine always, or cosine or tangent for that matter, always must go with the angle. So we have sine of 26.3 degrees. And it equals, now this is the opposite over the hypotenuse. Adjacent divided by the hypotenuse. Opposite divided by the adjacent, all right? And so we don't know what the opposite side is, so let's call that x, and it's going to be over 14.5. Now, I like to solve these without using my calculator at first. I'm going to put it in the calculator at the end. And so notice those 14.5s will divide out. I divided by 1, I multiplied by 1, I multiplied, so I multiplied it over here. So my x value is 14.5 times the sine of 26.3. So let's go to Desmos and see what that answer is. And when we come to Desmos, we have to tell Desmos we want to be in degree mode, because that's what we're using right now. We will use radians mode in this class, but right now we're in degrees mode. And so if you remember, it was 14.5 times the sine of 26.3. And we're just going to round to the nearest tenth, so we get 6.4. 6.4. Okay? Where are we? Here we are. All right, and so we said that this side here is 6.4. Whatever units, it doesn't tell us what the units are. All right? So let's continue with this 26.3. And keep in mind that this side now is the adjacent. All right, that's the adjacent. I'm going to move these inside here. All right, so this is the adjacent. And so now what we're going to do, we have the adjacent. We can use the opposite side, but they gave us this 14.5 here as the hypotenuse, so we're going to use that one. And where is the adjacent and the hypotenuse? Where's the A and the H together? Well, the A and the H together is right here, and so that means we're going to use cosine. So cosine of 26.3 degrees equals, again, let's call this y over 14.5. And hopefully it makes sense to you that we're going to multiply by 14.5 again. And we're going to go to Desmos. See if I can get it here. There we are. And now we're going to do 14.5 times the cosine of 26.3. And we would say 12.9, but we have to round up, so we're going to say 13.0. All right, so this value is 13.0. Okay. All right, so let's do something. Desmos will tell, or not Desmos, this will tell us what our values are here. And notice we got an answer of 6.4 here, and it matches 13.0, and it matches there. So that's how we're going to use our right triangle trig. Right? I know I took a long time explaining this. This is one example. We're going to do a lot of examples in class. So please, if you need to, go back, watch this video again. Use this mnemonic device right here. Memorize how to spell it, SOHCAHTOA. It's going to be key for you knowing how to do this with right triangles. Right? This is for right triangles only. Maybe I should add that in here. Oh, we're good. So this is for right, oh boy, I'll learn to spell today. Right triangles only. Okay? SOHCAHTOA for right triangles only. All right, sounds like a good marketing scheme. SOHCAHTOA for right triangles only. Hey guys, I appreciate you watching. Thanks for doing so. We'll see you in class.